solving and graphing inequalities. Now, as far as the solving goes, the solving happens just like we solve equations. First, you simplify both sides. Then you're going to do PEMDAS only backwards. You're going to do it backwards. So, in this first example here, simplify. First thing I'm going to do is distribute the -3. So I got -6x minus 3 is greater than or equal to 21. Then get rid of addition and subtraction. So I'm going to add 3 to both sides of the inequality. Just like an equation, there's like a line going through there. So we got -6x is greater than or equal to 24. Then get rid of multiplication and division. So we're going to divide by -6 on both sides. And we're left with x is, now here's the thing. One of the rules of inequalities is if you multiply or divide by a negative number, you must switch the inequality symbol. So greater than or equal to becomes less than or equal to, and then 24 divided by -6 is -4. So in order to graph this, we need a number line. And our number lines, we're always going to have 2 tick marks on it. When it's an equation like, or an inequality like this, 0 is going to be one of the tick marks, and then our answer is going to be the other one. So in this case, -4. -4 is to the left of 0, so -4 and 0 like that. Now, less than or equal to or greater than or equal to are solid circles. So this is a solid circle, and it says x is less than or equal to -4, so that means it's going to the left like this. This means that all the answers to the left of -4, -10, -1,000, are solutions to the original inequality. All right, now, these next 2 problems I have here, they're actually the exact same two problems. What I was going to do here is do a little proof as to why we have to switch the symbol. Let me show you why. Now, in these cases, we have x's on both sides of the inequality. So first thing first, we're going to simplify by getting the x's on one side. I'm going to move the little x. I'm going to move the 3x to the left side. So now I'm left with 2x plus 8 is greater than 6. Subtract 8 from both sides. And I'm left with 2x is greater than -2. And then I'm going to divide by 2 on both sides. And we get x is, now do I switch this symbol? This says -2 divided by 2. You only switch the symbol when you multiply or divide by a negative. This is not a negative, so we keep the symbol. -2 divided by -1 is -1. So to graph this, we have the point -1 and 0. Now, because it's greater than or less than are open circles, because we're not including -1. Is -1 greater than -1? No, but so that's why it's open. But it's greater than, which means that it goes this way. Now, suppose I did the exact same problem, except instead of moving the 3x first the way I did here, let's suppose I move the 5x instead. If I do this, I get 8 is greater than 3x minus 5x is -2x plus 6. Now, again, we get rid of addition and subtraction. Subtract 6 from both sides. And we would have 2 is greater than -2x. Divide by -2. Divide by -2. And we get 2 divided by -2 is -1 greater than x if we don't switch the symbol. Now, some of you are right. Smith, you were supposed to switch that. You're right. However, this is a reason why. If I read this backwards, this says x is less than -1, right? X, little tick mark there, is less than negative 1. But when we solved it the right way here, we got x is greater than negative 1. This is why if you multiply or divide by a negative number, you have to switch the symbol so that no matter which way we solve it, we always get the same right answer. All right. If you multiply or divide by a positive, you leave it alone. If you multiply or divide by a negative number, you have to switch the symbol.